Have you ever heard of the term anti-nutrient? Yesterday, when I was talking about iron, that kind of prompted me to talk about that one of the many anti-nutrients called phytic acid. Phytic acid is a form of phosphorus. It's found in like nuts, seeds, legumes, um, like for example, whole grains, brown rice, etc. And phytic acid actually binds and inhibits the absorption of essential minerals, mainly zinc and iron, but also copper and calcium to a lesser degree there. But that took me back to the iron deficiency and how we want to pair up foods with iron. So I wanted to explain that a little bit more. There are two forms of iron. There's heme iron, which is found in animal-based foods, and there is non-heme, which is plant sources of iron. So, like spinach, for example, and beans, things like that. And you'll also notice the beans and that are rich in iron are also rich in phytic acid. So, here's a few things. When we're looking at iron and we're looking at the absorption, yesterday when I was talking about how calcium inhibits the absorption of iron, I'm talking about non-heme iron. Calcium does not mess with heme iron. So for example, if you had milk with your steak, or you had cottage cheese with your chicken, that's not going to impair the absorption of iron. Now, however, if you are eating eggs and spinach, you've just decreased your iron intake, because eggs honestly aren't a great source of iron anyway. But even with eggs, they can impair that iron absorption. So if you had something like cottage cheese and oats, you're not going to be absorbing your iron. The reason why is because these two different forms of iron. The non-heme iron is what we call ferric iron, and that has to be broken down by one, stomach acid, and then vitamin C. The stomach acid and vitamin C are responsible for breaking down the non-heme iron from ferric to ferrous. Ferrous iron is the form of heme iron, which is the animal-based iron that the iron is already in. So it doesn't have to be broken down into the more absorbable form that is going to be... What's on my glasses? That is going to be absorbed in the duodenum, which is the first part of the small intestine. Got it. So then, whether it has to be broken down to the ferrous form. And once it gets to the ferrous form, it goes into the enterocytes, which is the intestinal cells. And then, once it enters the enterocyte, it can be stored short term as ferritin. Ferritin is also something that I highly recommend someone getting in their blood work. It's not a routine lab, but it is very beneficial to see what your iron stores are. And once it gets back into the blood, it goes back to ferric, so it can be transported around, and your body kind of has this gauge system on when we need iron or not. And that's why vitamin C is great, because it helps get from the ferrous form to the ferric form to the ferrous form. And other things like I mentioned with calcium, if you have iron deficiency anemia, I would still be cautious of eating calcium with your foods. Like I mentioned, the drinking milk with your foods, yogurt, cheese, dairy, things like the dairy sources. But that's something that it's just honestly all personalized. But I just wanted to touch base on that. And with the phytic acid, that is what can we do with phytic acid? So does that mean that you could never eat anything with phytic acid because it's just going to make you iron deficient? No, not necessarily. The best way to reduce what phytic acid does to the iron and zinc absorption is boiling. Also fermentation, like sourdough, for example, fermenting it and soaking your nuts, your beans. So people that are making a pot of beans, especially if you're down in the Midwest or the South, we eat a lot of beans. So soaking them overnight can help reduce that phytic acid, where it's going to inhibit that absorption of iron and zinc specifically.